Hi, I'm Randall Barney. We're here at the NAB show speaking with teleport, satellite, and technology providers about their customer solutions, and here's what they had to say.
So we've spent quite a deal of time over the last 5 or 6 years getting to better understand our customers' needs, especially as it relates to antenna controllers and tracking, and even taking that one step further, especially as it relates to Ka band requirements. And so our next generation controller, as an example, we have focused on taking what is essentially the basic antenna controller and making it so that it takes on far more impact and far more responsibility within the entirety of the transmission chain. And so the antenna subsystems are controlled within the controller because our customers want to have a smaller footprint in their earth stations, because they want to have more control over the satellite antennas, because they want to be able to do things with their controllers that, as part of the overall control system, that maybe they don't want to go out and buy a lot of different parts. An example for that might be the built-in spectrum analyzer that we have within the antenna controller. Most people buy a controller, it moves the antenna, tracks, does what it needs to do, then they go buy a separate spectrum analyzer, or maybe they buy a separate beacon receiver, or maybe they buy a separate carrier monitoring system. We have all of those built in to the next generation controller, to our NGC. The NGC also does things that, again, listening to our customers, understanding where they want the tracking stability within their antenna systems, again, especially at Ka band. So now the next generation controller ties in very closely with our subreflector tracking technology, which then allows us to use the NGC to monitor the environmental aspects of the antenna, environmental aspects of the area around the antenna, and to better control the subreflector tracking technology, the SRT, to compensate for moisture in the air, for solar distortion of the reflector, and all those sorts of things. So by taking a look at what our customers' real needs were, in terms of throughput onto the satellite, in terms of stability of the antenna structure, that's how we came up with the designs like we did for the NGC and our SRT. One of the challenges that we face as a company when we're designing new products is needing to filter out what appear to be an endless requirement from our customers to have very specific frequency bands or very specific tracking requirements, those sorts of things. We took the approach several years back that we were going to continue to design for the broadest possible use, yet not give up any of the benefits that we've already built into our products. For example, every new reflector or antenna system that we've designed in the earth station side of our business over the last 5 years, we have enabled and made sure that it can handle frequencies up to Q and V bands. So we no longer have to customize a new reflector every time somebody wants to step up in frequency. Same holds true with the way that we've dealt with our feed systems. A lot of different satellite operators, a lot of different customers want a very specific frequency within the feed system. We've designed and optimized most of our feed systems to be broadband so that one customer, when they buy a feed, it's not going to be unique to that customer, but in fact is going to be able to be applied across a wide segment of the customer base. And that enables us to have many more products that are broad enough in their scope to address a much larger matrix of opportunities.